If E and F are independent events, means we know that the intersection E and F is equal to probability of E into probability of F. We know the formula for P of A union B is P of A plus P of B minus P of A intersection B. Null set. If A intersection B is equal to null set, means therefore their probability of A and B is equal to 0. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now today in this session, I am going to discuss very important concept, that is regarding independent events of a probability. So in probability, let us discuss regarding the independent event. Now suppose, let us consider two events. E and F are two independent events, then so are they events E and F dash. So let us, in the previous class we have discussed regarding the problems on independent events. Now today I am going to discuss regarding very important theorem. So this is nothing but a theorem, theorem number 1. Suppose if E and F are any two independent events, if E and F are independent events, then E and F dash, whether E and F dash are also independent event or not. So to verify whether E and E dash, the complement of F. Now let us come to the solution. What is the solution here? Since it is given that E and F are independent events, if E and F are independent events, means we know that the intersection E and F is equal to probability of E into probability of F. Let us represent this as equation number 1. So probability of E and F, E intersection F is equal to probability of E into probability of F, because it is given E and F are independent events. Now let us draw the Venn diagram for this. So this is E and F. The intersection of these two is E intersection F, and the complement of this is E dash intersection F dash. Okay, this is E dash intersection F dash, the set. Now here this part, this is E intersection F dash, and this is E dash intersection F. See here. So from this Venn diagram, E and F are two events, E and F are the two events. The intersection of E and F is, this is E intersection F, this part is E intersection F, and this one is E intersection F dash, whereas this is E dash intersection F. Okay, this is the sample space. Now from the Venn diagram, it is clear that E and F, E intersection F and E intersection F dash, these two are mutually exclusive events. That is E intersection F dash and E dash intersection F. From these two, that is E intersection F and E intersection F dash, are mutually exclusive events, and also we know that E is equal to E intersection F union E intersection F dash. So the union of these two will give the value of E. So therefore the probability of E is equal to, what is the probability of E? The probability of E can be written as probability of E intersection F plus probability of E intersection F dash. Probability of E is equal to probability of E intersection F plus probability of E intersection F dash. Now probability of E intersection F, so just interchange this, probability of E minus probability of E intersection F is equal to probability of E intersection F dash. See here, since these two, that is E intersection F and E intersection F dash are mutually exclusive events, and also the union of these two. So E intersection F union E intersection F dash is equal to E. Therefore, the probability of this event E is equal to probability of E intersection F plus probability of E intersection F dash. Interchange this, just transfer this. So if you transfer, probability of E minus probability of E intersection F is equal to probability of E intersection F dash. So this, since we know from equation number, what is probability of E and F? E and F is equal to probability of E into probability of, substitute here from equation number 1, P of E intersection F is P of E into P of F. So we can take P of E as common factor. This is taken out, P of E out. What is remaining? Probability of E out, 1 minus probability of F. Since we know, since 1 minus probability of F is always equal to probability of F dash, the complement. So 1 minus P of F is nothing but P of F dash. So therefore P of E into P of F dash, that means E and F dash are also independent events. This is very important theorem it is. Actually, it is a theorem. So, what is the theorem here? If E and F are independent events, then whether E and F dash are also independent event. Verify whether E and F dash for any two independent events, E and F are independent. Then verify whether E and F dash, the complement of F, is also independent or not. So, very simple. What is given? Since E and F are independent events, therefore, the probability of E intersection F is equal to probability of E into probability of F. Let us represent this equation number 1. Then, let us draw the Venn diagram for this. From this Venn diagram, if this is E and F, this is intersection of E and F is this, E intersection F is this one. Intersection of E and F dash is this part. E dash intersection F represents this part, and E dash intersection F dash. Okay. Now, since from the Venn diagram, it is clear that E intersection F and this E intersection F and E intersection F dash are mutually exclusive events. So, therefore, E can also be written as the union of this, that is E intersection F or E intersection F dash. Now, the probability of E is equal to probability of E and F plus probability of E intersection F dash, E and F dash. Since we know from equation probability of E intersection F, before that let us transfer this probability of intersection F dash as it is and transfer this P of E minus P of E intersection F. P of E minus probability of E intersection F is nothing but probability of E into probability of F, that is from equation number 1. I can take P of E common factor, P of E out, what is left is 1 minus P of F. Since we know the complement of F is 1 minus P of F is equal to P of F dash. So, this can be written as P of F dash. So, probability, therefore, probability of E intersection F dash is equal to probability into probability of F dash, means this E and F are said to be independent event. So, E and F dash is also an independent event. Okay, that is regarding the first theorem is concerned. Hope you followed. Now, let us come to the next theorem. What is theorem number 2? So, this is also a theorem number 2. Suppose if A and B are two independent events, then the probability of occurrence of at least one of A and B given by probability of A dash into probability of B dash, the complementation again here. So, the complement of A dash and complement of A and complement of B. Suppose if A and B are any two independent events, for any two independent events A and B, the probability of occurrence of at least one of A and B, the probability of occurrence of one of A and B is given by 1 minus probability of A dash complement of A into probability of B dash, the complement of B. So, what is to prove is, if for any two events A and B, the probability of occurrence, that is nothing but at least probability of A, at least one of A and B is 1 minus P of A dash into P of B dash. Now, let us come to the proof. So, here let us consider, we know that the probability at least one of A and B is probability of A union B, 1 of A and B. So, probability of A union B is equal to, we know the formula for P of A union B is P of A plus P of B minus P of A intersection B. So, P of A plus P of B minus P of A intersection B. So, again this is independent event, since probability of A intersection B is also equal to probability of A into probability of B. Substitute here. So, probability of A intersection B is equal to probability of A into probability of B. So, P of A plus P of B minus P of A into P of B. So, here you can take P of B as common factor, P of A plus P of B out, what is left is 1 minus P of A. Since we know that the complement of A, P of A dash is equal to 1 minus probability of A. So, 1 minus P of A can also be written as P of A dash. Now, so P of A plus P of B into P of A dash, this P of A is also equal to this, if I transfer this, P of A is equal to 1 minus P of A dash. So P of A is also equal to 1 minus P of A dash plus P of B into P of A dash. So here in this you can take P of A dash common factor, 1 minus P of A dash. Here, this can also be written as 1 minus P of B. So if you multiply 1 minus P of A dash into 1 is P of A dash, minus into minus plus P of A dash into P of B is P of A dash and B dash. So therefore this equation can be written as 1 minus P of A dash into probability of 1 minus B. So since we know this, 1 minus probability of B is also equal to probability of B dash, the complement. So 1 minus P of B is also equal to probability of B dash. So therefore this is equal to 1 minus P of A dash into P of B dash. So hence at least probability at least one of A and B is 1 minus probability of A dash into probability of B dash. This is also a very important theorem. Okay, these are the two theorems based on the independent events. Okay, so let us consider few examples based on the independent events. Now this is the first problem. E and F with the events. What is given? Given that probability of E is 3 by 5, probability of F is 3 by 10, and the probability of E intersection F, E and F is 1 by 5, or E and F are independent events. So to verify whether E and F are independent events. Now what is to verify here? To verify whether the E and F are independent events, prove that probability of intersection F is equal to probability of E into probability of F. Okay, substitute the values. What is probability of intersection F? It is 1 by 5 is equal to probability of E. Probability of E is 3 by 5 into probability of F. What is F? It is 3 by 10. So this can be written as 9 divided by 50. 9 divided by 50. So is it possible to divide? We cannot divide 9 by 50. So that means 1 over 5 is not equal to 9 by 50. Therefore, since probability of E intersection F is not equal to probability of E into probability of F, therefore E and F are not, they are not independent events. E and F are not independent events. So this is not an independent event. See here, probably what is to prove? Two events E and F are said to be independent if probability of E intersection F is equal to probability of E into probability of F. So verify whether they are equal or not. Probability of E and F, E intersection F is 1 by 5. Probability of E is 3 by 5 and the probability of F is 3 by 10. 1 over 5 is equal to 3, this is 9 by 50. 1 by 5 is not equal to 9 by 50. So probability of E and F is not equal to probability of E into probability of F. Therefore, E and F are not independent event. They are not independent event because this condition is not satisfied. Okay, that's regarding this problem is concerned. Very important. You may expect this type of questions for 2 or 3 marks. Okay. Now let us come to the next problem. Problem number 2. Given that the events A and B, there are two events. Given that events A and B such that probability of A is equal to 1 by 2, probability of A is 1 by 2, probability of A or B, A union B is equal to 3 by 5, and the probability of B is equal to P. Find P if they are mutually exclusive and they are independent. So this is given condition. So what is given? Probability of A is 1 by 2, probability of A or B is 3 by 5, and probability of B is equal to P. What is required to find is probability of to find P. What is required to find is P is to be determined. The condition are, first condition they are mutually exclusive and the second condition is independent event. So mutually exclusive and the second condition is independent event. So if such is the case, find out the value of P. Okay. So if two events A and B are said to be mutually exclusive events, now let us come to the solution. Two events A and B are said to be mutually exclusive events if the intersection A intersection B is equal to null set. If A intersection B is equal to null set means therefore their probability of A and B is equal to 0. This is the first condition given. What is the first condition given? A and B are mutually exclusive events. Means for mutually exclusive events, A intersection B is a null set. Intersection is a null set. So if A intersection B is a null set, means the probability of A intersection B is equal to 0. Now therefore, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. We know this formula. Since probability of A or B, A union B is equal to probability of A plus probability of B minus probability of A and B. So that is what is given here. Probability of A union B is 3 by 5 is equal to probability of A is 1 by 2 plus probability of B is P minus probability of A intersection B is a null set. This is given. That's it. Simplify, you will get the value of P. That's all. See here, for the first answer, first mutually exclusive. Since A and B are mutually exclusive, if A and B are mutually exclusive events, then the intersection is a null set. A intersection B, A and B is null set. Therefore, the probability of A intersection B is equal to 0. Since we know that probability of A or B, A union B is equal to probability of A plus probability of B minus probability of A intersection B. Probability of A union B is given, that is 3 by 5 is equal to probability of A is 1 by 2 plus probability of B is P minus A intersection B is equal to 0. Now, so simplify this. This can also be written as 3 by 5 minus 1 by 2 is equal to P. So therefore, P is equal to, take LCM, 5 2s are 10 is LCM, 3 2s are 6 minus 5. So P is equal to 1 by 10, 1 divided by 10. See here, let me explain once again. So what is required to find is P. 3 by 5 minus 1 by 2 is equal to P. Take LCM, 5 2s are 10, cross multiply, 3 2s are 6 minus 5, 6 minus 5 is 1 by 10. So therefore, the value of P is equal to, 1 divided by 10 for this mutually exclusive events, means the value of P is equal to 1 by 10. Now the second part is independent. So this is very simple. You know the condition for independent events. Substitute, you will get the answer. That's it. Second condition is independent events. For independent events, suppose, since you know A and B are independent, if and only if probability of A intersection B, A and B is equal to probability of A and probability of B. Probability of A into probability of B. Now, second condition, I will do here second. Since A and B are independent events, therefore, the probability of A and B, A intersection B is equal to probability of A into probability of B. So, what is given here? Probability of A is 1 by 2 into probability of B is equal to P. And what is A intersection B? This is a null set. A intersection B is a null set. I will write this. Since what is given? A intersection B is not given. So P of A intersection B is equal to half of P. So therefore, probability of A intersection B is equal to half of P. Listen to me here. Once again, I will explain it. See here. Since A and B are independent events, therefore probability of A and B is equal to probability of A into probability of B. That is, probability of A intersection B is equal to probability of A is 1 by 2 and probability of B is P. So this is equal to of 1 by 2 times P. Since probability of A union B is also equal to probability of A plus probability of B minus probability of A intersection B. This is equal to probability of A plus probability of B minus, since these are independent event, so whenever independent event means the probability of A intersection B is probability of A into probability of B. Okay. Since A and B are independent events, therefore A intersection B is equal to probability of A into probability of B. That's what I have written here. Now substitute here. What is probability of A? 1 by 2 plus probability of B, P minus probability of A into B. Probability of A into probability of E is 1 by 2 into P. Simplify this, you will get the answer. So here 2 is the LCM, 1 plus 2P minus P. So this is equal to 1 plus P divided by 2. Since this is given, what is given? The probability of A union B is equal to 3 by 5. Okay, substitute here. I'll substitute here. Since this is equal to 3 by 5, the probability of A union B is 3 by 5. So 3 by 5 is equal to 1 plus P divided by 2. Cross multiply, 3 2s are 6 is equal to 5 plus 5P, or 6 minus 5 is equal to 5P. Therefore, 5P is equal to 1, P is equal to 1 divided by 5. The value of P whenever A and B are independent events are 1 by 5. That's it. Okay. So, listen to me, I will explain once again. Since A and B are independent events, therefore, probability of A and B is equal to probability of A into probability of B. So, what is probability of A? 1 by 2. Probability of B is P multiplied half of B. Since we know that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B, A and B. P of A plus P of B. Since A and B are independent events, so for independent events, A intersection B, A and B is equal to probability of A into probability of B. Substitute the values. Probability of A is 1 by 2, probability of B is P, and probability of A into probability of B is 1 by 2 into P is 1 by 2 times P. Take LCM, 2 is the LCM, 2 gets cancelled, 1 plus 2P minus 2 gets cancelled P. So 1, 2P minus P is P, 1 plus P divided by 2. Since A union B is equal to 3 by 5, that is given, 3 by 5 is equal to 1 plus P by 2, cross multiply, 3 2s are 6 is equal to 5 plus 5P, 6 minus 1 is 5P. So that is 5P is equal to 1, therefore P is equal to 1 by 5. So therefore, for independent events, the value of P is equal to 1 by 5, and for mutually exclusive events, the value of P is equal to 1 by 10. So, for this is P is equal to 1 by 10, or independent events P is equal to 1 by 5. This is the solution for this given problem. Hope you followed this. Okay. Let us come to the next problem. Now, what is the problem? Problem number 3. This is also a very important problem. Let E and B 3 marks question. This is, let E and B be the independent events with probability of A given. What is given? Given that probability of A is equal to 0.3, probability of B is equal to 0.4. What is required to find is first probability of A and B, probability of A or B, probability of A by B, B is already occurred, and the probability of B by A is already occurred. Now let us come to the solution part. The first one, what is required to find is the probability of A and B. Since A and B are independent events, if A and B are independent events, for independent events, the probability of A and B is always equal to probability of A into probability of B. If A and B are independent events, the probability of A and B, A intersection B, is equal to probability of A into probability of B. What is P of A? P of A is 0.3 into probability of B is 0.4. 0.3 into 0.4 is 0.12. So the first answer is 0.12. 3 4s are 12. So probability of A intersection B is equal to 0.12. For the second, what is required to find probability of A union B, A or B? So for this, what is the formula we are going to use? Probability of A or B is equal to probability of A plus probability of B minus probability of A and B. That is, probability of A union B is equal to P of A plus P of B minus P of A intersection B. What is probability of A? 0.3. What is probability of B? 0.4. Minus what is A intersection B? 0.12. Simplify this. This is 0.3 plus 0.4 is 0.7 minus 0.12. Simplify this. So this is nothing but 0.70 minus 0.12. Subtract this. 10 minus 2 is 8, 6 minus 1 is 5. So 0.58. This is equal to 0.58. So the second answer is 0.58. Therefore, the probability of A or B is equal to 0.58. The first answer is the probability of A and B is equal to 0.12. The second answer is the probability of A or B is equal to 0.58. Okay, let me explain. See what is given. Probability of A is 0.3. Probability of B is 0.4. What is required to find is first probability of A and B. Since probability of A and B is equal to probability of A into probability of B, because A and B are independent events. Since A and B are independent events, therefore probability of A and B is equal to probability of A into probability of B. That is 0.3. 0.3 into 0.4 is 0.12. So this is 0.12. Next, the second condition. Second answer is to find the probability of A or B. So probability of A or B, A union B is equal to P of A plus P of B minus P of A intersection B. That is 0.3 plus 0.4 minus 0.12. So 0.3 plus 0.4 is 0.7 minus 0.12 is nothing but 0.70 minus 0.12 is 0.658. So therefore, the probability of A union B, A or B is equal to 0.58. These two are gone. Now let us come to the third part. What is required to find? The probability of A by B. Already B is occurred, and the probability of B by A is already occurred. Okay. Now let us come to the third part. Probability of A by B. Now what is the formula for this? Probability of A by B. B is already occurred is given by probability of A and B divided by probability of B. Now since A and B are independent events, you can write probability of A intersection B is probability of A into probability of B divided by probability of B. This two gets cancelled. This is equal to probability of A. What is probability of A? Probability of A is equal to 0.3. So therefore, probability of A is equal to 0.3. This is the required answer. That's it. Or otherwise, you can also write probability of A intersection B is 0.12 is divided by probability of B is 0.4. This is equal to 0.3. Or you can also write like this. Okay. Now the third one, probability of B by A. This is equal to probability of B by E is again probability of A intersection B divided by A is already occurred, probability of A. Since A and B are independent events, therefore probability of A intersection B is equal to probability of A into probability of B divided by probability of A. You can cancel these two. This is equal to probability of B. What is probability of B? 0.4. The answer is 0.4. Or you can also write like this. What is probability of A intersection B? Probability of A intersection B is equal to 0.12 divided by probability of A. Probability of A is 0.3. So this is equal to 0.4. Any method you can use to solve this. That's it. Okay. Listen to me here. So probability of A by B is equal to probability of A and B divided by probability of B. That is, since A and B are independent events, probability of A intersection B is equal to probability of A into probability of B divided by probability of B. Cancel it, you will get probability of A is 0.3. Or otherwise, straight away you can substitute the answer 0.12 divided by 0.4. That's equal to 0.3. So the answer is 0.3. Probability of A by B is 0.3. Now fourth part. Probability of B by A. A is already occurred is given by probability of A intersection B by probability of A. Probability of A intersection B is 0.12 divided by 0.3 is 0.4. Or you can also use this method. Probability of A, since A and B are independent, probability of A intersection B is probability of A into probability of B divided by probability of A. This two gets cancelled. Probability of B you will get. What is the probability of B? 0.4. So the required answer is the first one. For first one, probability of A by B, it is, for this is 0.3 and this is 0.4. That's it. Okay. So that's all the few theorems based on independent events and the problems based on a independent event. So that's all for today's session. Let us meet with different concepts in the next class. Thank you. Thank you very much.